Good day, everyone. We are going to talk about the database models. There are two types of database models, which are the hierarchical data models and the network data models. Hierarchical data model is the oldest type of the data models, and it was developed by IBM in 1968. It organizes data in a tree-like structure. Hierarchical model consists of the following. It contains nodes which are connected by branches. The topmost node is called the root node. If there are multiple nodes appear at the top level, then these can be called as root segments. Each node has exactly one parent. One parent may have many child. Moreover, this model helps to represent one-to-many relationships among two data types. As shown in the diagram, the nodes connect to each other, forming a parent-child relationship. Each child node will only have a single parent. As you can see in the picture below, this is an example of a hierarchical model. Para siyang family tree. Hierarchical database models arranges data in a structure similar to a tree. First, there is the main root, which is the start of the tree. Other data are arranged under the main root. Furthermore, other nodes connect to the main node as children nodes. Another set of nodes are connected to these children nodes. Further information, in this model, to store data, hierarchy methods is used. To organize record, it uses tree structure. Records are linked with the help of pointers. Insertion anomaly exists in the model. In example, child node can be inserted without the parent node. Deletion anomaly exists in the model. In example, it is difficult to delete the parent node. It is used to access the data, which is complex and asymmetric. This model lacks data independence. The next one is the network database model. What is network database model? A network model is an extension of a hierarchical model, which arranges data in a structure similar to a graph. Unlike in a hierarchy model, a node in the network model can have multiple parents. Furthermore, the data in the database created using the network model will have more relationships. This type of linking among data helps to access data easily and much faster. This model helps to represent many-to-many relationships. As you can see in the picture below, this is an example of network model. Network data model, it is the advanced version of the hierarchical data model to organize data. It uses direct graphs instead of the tree structure. In this child can have more than one parent, as you can see in the previous picture. It uses the concept of the two data structures, in example, records and sets. Further information, in this model, you could create a network that shows how data is related to each other. To organize records, it uses graphs. Records are linked with the help of linked lists. There is no insertion anomaly, there is no deletion anomaly, and it uses the access data, which is complex and symmetric. This is partial data independence in this model. There is partial data independence in this model. To conclude with, the difference between the hierarchical data model and the network data model is that hierarchical data model is to organize records, and it uses tree structure. Also, records are linked with the help of pointers. While network data model is to organize records and uses graphs and records that are linked with the help of the linked list. That is the difference between the hierarchical data model and the network data model.
Types of database models. Fundamental concept in the relational data model. Relation, also known as a table or file, is a subset of the Cartesian product of a list of domains characterized by a name, and within a table, each row represents a group of related data values. A row or record is also known as a tuple. The columns in a table is a field and also referred to as an attribute. You can also think of this way. An attribute is used to define the record, and a record contains a set of attributes. The relation model is the most widely used data model. The relation data model describes the world as a collection of interrelated relations or table. Almost all relation database model are modern commercial database management system. The standard database access language called structured query language is the SQL. Table. A database is composed of multiple tables, and each table holds the data. A database that contains 3 tables. The blue part is the database. Inside the database is the tables. In each of these table holds the data. Right? Like this picture. Column. A database store pieces of information or facts in an organized way. Understanding how to use and get the most out of the databases requires us to understand that method of organization. The principal storage units are called columns or fields or attributes. These house the basic components of data into which your content can be broken down. When deciding which fields to create, you need to think generically about your information. For example, drawing out the common components of the information that you will store in the databases and avoiding the specific that distinguish one item from one another. Look at example of ID card to see the relationship between fields and their data. Like this one, the field name is the first name and the data is the first name is the Isabel, and the field name, family name, the data is the last name or Willan. The field name is nationality, the data is British. The field name is salary, the data is the number. The field name is date birth, the data is 15 September 1983. The field name is marital status, data is single. Field name shift, the data is Monday, Wednesday. The field name is place of issue, the data is Addis Ababa. Field name valid until, data is 17 December 2003. Domain. A domain is the original sets of atomic values used to model data. By atomic value, we mean that each value in the domain is indivisible as far as the relation model is concerned. For example, the domain of marital status as a set of possibilities: married, single, divorced. The domain of shift has the set of all possible days: Monday, Tuesday, Wednesday, and so on. The domain of salary is the set of floating points numbers greater than 0, less than 200,000. The domain of first name is the set of characters, strings that represents names of people. In summary, a domain is a set of acceptable values that a column allowed to contain. This is based on various properties and the data type for the column. Records. Just as the content of any one document or item needs to be broken down into its constituent bits of data for storage in the fields, the link between them also need to be available so that they can be reconstituted into their whole form. Records allow us to do this. Record contains fields that are related, such as a customer or an employee. As noted earlier, a tuple is another term used for record. Records in fields form the basis of all databases. A simple table gives us the clearest picture of how records and the fields work together in a database storage project. The simple table example shows us how fields can hold a range of different sorts of data. This one has a record ID field. This is an ordinal number. Its data type is an integer. A public field. This is displayed as a day, month, year. Its data type is date. An author field. This is displayed as initial. Surname, its data type is text. A title field text. Free text can be entered here. Take the example down the table below. This is show how fields can hold a range of different sorts of data. And also, you can command the database to sift through its data and organize it in a particular way. For example, you can request that selection of records can be limited by date. Number 1, all before a given date. Number 2, all after a given date. Number 3, all between two given dates. Similarly, you can choose to have records sorted by date because the field or record containing the data is set up as a data field. The database reads the information in the data field not just as a number separated by slashes, but rather as dates that must be ordered according to a calendar system. Degree. The degree is the number of attributes in a table. In our example, in the last table, the degree is 4. Properties of a table. A table has a name that is distinct from all other tables in the databases. There are no duplicate rows. Each row is distinct. Entries in columns are atomic. The table does not contain repeating groups or multi-valued attributes. Entries from columns are from the same domain based on their data type, including number, numeric, integer, float, small int, character, string, date, logical, true or false. Operations combining different data types are disallowed. Each attribute has a distinct name. The sequence of column is insignificant. The sequence of row is insignificant. Several of the terms used in this chapter are synonymous. The terms in the alternative one column are mostly commonly used. Atomic value. Each value in the domain is indivisible as far as the relation model is concerned. Attribute is the principal storage in unit database. Columns is to see attribute. Degree is the number of attributes in the table. Domain is the original sets of atomic values used to model data, a set of acceptable values that a column is allowed to contain. Field is to see attribute. File is to see relation. Record contains fields that are related to see tuple. Relation is a subset of the Cartesian product of a list of domains characterized by a name and technical term for table or file. Row is to see tuple. Table is to see relation. Tuple is a technical term for row or record. And lastly, the structured query language SQL is the standard databases access language. Object-oriented databases model. Object-oriented databases are a type of databases management system. Different database management systems provide additional functionalities. Object-oriented databases add the database functionality to object programming languages, creating more manageable code bases. Object database definition. Object database define an object database is managed by an object-oriented database management system, or OODBMS. OODBMS stands for Object-Oriented Databases Management System. The database combines object-oriented programming concept with relational database principle. This is where the data is represented in the form of objects. An object-oriented database is a database system that can work with complex data objects, that is objects that mirror those used in object-oriented programming languages. In object-oriented programming, everything is an object, and many objects are quite complex, having different properties and methods. Objects are the basic building block and an instance of a class, where the type is either built-in or user-defined. Classes provide a schema or blueprint for objects defining the behavior. Methods determine the behavior of a class. Pointers help access elements of an object database and establish relations between objects. In the picture, the object-oriented programming have different methods. The methods are the polymorphism, inheritance, encapsulation, and for the relational database is the integrity, concurrency, and query processing. They have different methods, but the pointers help access elements of object database and establish relation between objects. Object-oriented databases directly deal with data as complete objects. All the information comes in one instantly available object package instead of multiple tables. These characteristics make object databases suitable for projects with complex data which require an object-oriented approach to programming. An object-oriented management system provides supported functionality catered to object-oriented programming where complex objects are central. This approach unifies attributes and behaviors of data. In the table, instead of making multiple tables, the OODBMS, all the information is available in one package. They have different methods. Object-oriented programming concepts. Object-oriented databases closely relate to object-oriented programming concepts. The four main ideas of object-oriented programming are polymorphism, inheritance, encapsulation, abstraction. These four attributes describe the critical characteristics of object-oriented management systems. Polymorphism is the capability of an object to take multiple forms. This ability allows the same program code to work with different data types. Both car and bike are able to brake, but the mechanism is different. In this example, the action brakes is a polymorphism. The defined action is polymorphic. The result changes depending on which vehicle performs. Polymorphism is the method in an object-oriented programming language that performs different things as per the object class, which calls it with polymorphism. A message is sent to multiple class subjects and every object responds appropriately. Inheritance. Inheritance creates a hierarchical relationship between related classes while making parts of code reusable. Defining new types inherits all the existing class fields and method class further extends them. The existing class is the parent class while the child class extends the parent. For example, a parent class called vehicle will have child classes car and bike. Both child classes inherit information from the parent class and extend the parent class with new information depending on the vehicle type. Inheritance enables you to share attributes between objects such that a subclass inherits attributes from its parent class. Subclasses must include the same database field or fields as the parent class for their primary key, although the primary key can have different names in these two tables. Encapsulation. Encapsulation is the ability to group data and mechanisms into a single object to provide access protection. Through this process, pieces of information and details of how an object works are hidden, resulting in data and function security. Classes interact with each other through methods without the need to know how particular methods work. Encapsulation and object-oriented means an object contains both the data structures and the methods to manipulate the data structures. The data structures are internal to the object and are only accessed by other objects through the public methods. As an example, a car has descriptive characteristics and actions. You can change the color of a car, yet the model or make are examples of properties that cannot change. A class encapsulates all the car information into one entity where some elements are modifiable while some are not. This is an example of encapsulation. Abstraction. Abstraction is the procedure of representing only the essential data features for the needed functionality. The process selects vital information while unnecessary information stays hidden. Abstraction helps reduce the complexity of model data and allows reusability. For example, there are different ways for a computer to connect to the network. A web browser needs an internet connection. However, the connection type is irrelevant. An established connection to the internet represents an abstraction, where areas, the various types of connection represent different implementation of the abstractions. Abstraction is a process of hiding unwanted or irrelevant details from the end user. It provides a different view and helps in achieving data independence, which is used to enhance the security of data. Object-oriented database example. There are different kinds of implementation object bases. Most contain the following features. First feature is the query language. The description is a language to find objects and retrieve data from the database. Second one, transparent persistence, ability to use an object-oriented programming language for data manipulation. Asset transactions guarantee all transactions are complete without conflicting changes. Database caching creates a partial replica of the database, allows access to a database from program memory instead of a disk. Recovery, disaster recovery in case of application or system failure. Object-oriented databases, advantages and disadvantages. Every database modeling technique has a disadvantage and advantages. Before opting in for object-oriented databases, you must know the available languages in addition to application intent. The advantages, the main advantages are complex data in a wider variety of data types compared to MySQL data types. Easy to save and retrieve data quickly. Seamless integration with object-oriented programming languages. Easier to model the advanced real-world problems. Extensible with custom data types. The disadvantages. Some disadvantages include not as widely adopted as relation databases, not universal data model, lacks theoretical foundations and standards, does not support views, high complexity causes performance issue, cause a lag, and adequate security mechanism and access rights to objects do not exist.
Models. There are two types of models. First, the hybrid database model. A hybrid database is a balanced database management system offering high-performance data processing in main memory, along with huge storage capacities of the physical disk. What is a hybrid database? A hybrid database offers the characteristics of both an in-memory database and an on-disk database in a single integrated engine. Hence, data can be stored and operated either only in the main memory only or in the on-disk or in the combination of both. A good hybrid database should be fully distributed and must possess high availability, reliability, and scalability. A hybrid database is the one that employs both relational and NoSQL database methods in a single DB instance or database. The unified arrangement of both the kinds of database permit extraordinary flexibility and vigorous functionalities. Furthermore, these days, the definition of hybrid database is not just restricted to this data storage sense, but a hybrid database of the present day is a lot more than that. There can be instances where the software apps can take even more advantage by employing different solutions within the application for specific tasks. As most of the organizations are now moving to cloud, hence hybrid databases need to be hybrid in the architectural sense as well as combine the use of public and private clouds. At times, a hybrid database is also defined as the integration of relational and NoSQL databases. A hybrid databases enjoys the benefits of both relational and NoSQL databases and eliminates their limitations. For the applications that require high-speed transactions and quick response, for the execute complex queries on data in real time, it is more suitable to combine various database technologies for particular processing needs. A hybrid database offers considerable advantages over in-memory as well as on disk. The hybrid database consumes physical disk for storing and retrieving data, but still, it makes use of memory for the data which is in active use to boost the performance. The combination of both relational and NoSQL database technology generates a better system with higher availability, scalability, and performance. As a hybrid database supports both the types of databases, one of the obvious benefits of a hybrid DB is its flexibility. Using a hybrid DB, you can maintain a balance between performance cost and persistence. To fully understand the benefits of a hybrid database, let us first explore the benefits and limitations of the in-memory database and on-disk database individually. An in-memory database will also be considerably faster than an on-disk database as the data exists directly in RAM. The response time is very quick and latency is extremely low or microsecond scale. Conversely, the limitations is that the RAM is very costly that a traditional hard disk and it possesses a very little storage capacity. On the other hand, on these databases have huge storage capacity and the storage is quite cheap, but on this database tend to have poor performance at the disk or I/O operation is very expensive. And the design of the disk resident database frequently spends a lot of CPU resources in order to optimize the disk access patterns. We will understand the architecture of the hybrid database through the example of a hybrid database system designed for the storage and management of big data. This is the example. Let us consider a hybrid system made of MySQL database or Relational and Mongo database or NoSQL. Data is classified into a structured and an unstructured category. The structured data is sent to MongoDB or database, while the selection of the database for unstructured data relies on the mode in which the applications gets executed. In hybrid mode, data is sent to Mongo database, and in SQL mode, data is sent to the MySQL database. So how do hybrid databases work? For resource constrained and high performance system, a hybrid database is produced by the fusion of two systems, i.e. and memory database and on-disk database. It lets the developer join both the database models and memory and on-disk in a single database instance. The underlying working of the hybrid databases is based upon the HTAP or hybrid transactional and analytical processing functionality. For data storage, both the medium type, i.e. and memory and on-disk are available inside a single application. This permits customers to manage trade-offs between latency, cost, and storage preservation options. For customers and applications, the variance in operations crosswise storage types will be negligible, as data manipulation will be consistent across all tables. However, cost savings can be significant. Hybrid databases employ optimizers to automatically choose the most suitable execution plan based on the statistics and the existing indexes to improve the overall performance irrespective of the data's location. The hybrid database optimizes the transactional and analytical queries by supporting both row-based or for transactional queries and column-based storage for analytical queries. With a single DB or database instance, all the data is kept in a manner that optimizes the current operation. Best practices for implementing a hybrid database system: select the right hybrid model based upon your data. Cost, performance, and management requirements ensure a scalable database solution that meets your business needs, i.e., all while sustaining security, accessibility, flexibility, and interoperability within your present infrastructure. Try to keep your data movement minimum and maintain a simple architecture. Prepare for hybrid implementation, define the workflows well, review data placement, i.e., where to keep the data and how to fetch it. Alter your security approach. Check for any security issues in data transfer between on-premise and cloud resources. So, try to maintain the following 3 competencies. First, the integration competency, that the capability to connect distinct streams of data across the organization in an agile, efficient, and progressive way. Second, the information competency, the capability to handle meaning and context and thus the business value of data. And lastly, transformation competency, the capability to do the complex cross-functional changes in the business as demanded by market conditions, technology advances, and business opportunities, not just once, but as a continuing process. In some situations, switching from one or more RDBMS to no SQL database might not be beneficial. In these circumstances, it might be a better choice to create a hybrid system. The best example of this hybrid database is Altibase. Altibase is a hybrid database that simultaneously supports in-memory and disk storage into a single database solution. The architecture of Altibase permits the use of memory tables for high performance and disk tables for cost-effective storage, and also data stacks. Data Stacks Enterprise is a distributed hybrid cloud database developed on Apache Cassandra. This database is created for a hybrid cloud. It provides a single platform for all kinds of applications anywhere on my cloud. It supports all models, i.e. key value, JSON, graph, and tabular. So, multidimensional database. The second model. Multidimensional database system provide a multidimensional view of data for predictive planning and analytical applications. A multidimensional database provides significant benefits over a relational database. Multidimensional database applications that run on RPAS use multidimensional databases to store data, records in the master database, and multidimensional worksheets are used to present this data. So, this matrix below is an example of an array that contains two dimensions stored in an item. Arrays are the fundamental components of multidimensional databases. These dimensions contain two possessions each. First, they store or Minneapolis and Atlanta, and the item, the copy paper and photo paper. Dimensions. In RPAS, each axis in a multidimensional array is called a dimension. So in the example above, the dimensions are stored below, dimensions are stored and item. Multidimensional data is easier to recognize when it is presented as an array rather than a relational database. In the previous two-dimensional database example, it is easy to see that there are two dimensions, item and store, and that each dimension contains two positions. For example, the sales information for copy paper sold is grouped into one row and can easily be totaled. So, three-dimensional relational. The relational database example can be extended by adding a third dimension to the dataset. In the following example, the dimensions customer type is added to the table. These dimensions contains two possible positions, trade business and general public business. The addition for one dimensions with two positions actually doubles the number of rows in the table. This method of presenting data is difficult to handle because the table's length expands considerably with the addition of each new dimension. So, how multidimensional databases handle additional dimensions? A multidimensional structure accepts the addition of new dimensions while providing the ease of data analysis. There is now a three-dimensional 2x2x2 array. See the illustration below that contains 8 cells rather than a two-dimensional or 4x8 array that contains 32 data cells. The data is still sorted and presented in the same manner. The following figure shows a three-dimensional data array. So, four-dimensional data array, or the three-dimensional data array can be expanded to 4 dimensions by adding the dimension of time. So, example of 4-dimensional array, 4 dimensions are more difficult to understand. So, imagine an array that is similar to the figure below for each of the 12 months of the year, 12 positions in the time dimensions. So, that's all, and thank you.
Holy moly, moly, moly.
Iki MANAWATAO. Edwin MANGANAAN. Carter MARAYA. Mr. Denver Palmiano. ITC 100 instructor.